Hello students, myself Manuj from Scholars Forum. Again I welcome you all to this homemade video series of class 11th and class 12 topics. Please pardon the background noise, as you know that this video is being recorded at my home. So in the previous video we discussed about stoichiometry. We just started the stoichiometry topic. We discussed about limiting reagent. If you wish to go through those videos, you can find the link right up here. And in this video we will be discussing something about mixture of reactant. Okay. Now, let me inform you one more time. I have attached one DPP at the comment section and in the description of this video. So please go through that DPP after finishing the lecture. Okay. Now let's see let's start with Gaseous law of combining volume. Gaseous law of combining volume. What it says, if we have a gaseous reaction, what is the meaning of gaseous reaction? Gaseous reaction means reaction in which reactants are in gas state. Okay, so if we have a gaseous reaction, so in gaseous reaction, reactant react in simple ratio of volume. Okay, gas reacts in simple ratio of volume. Now, let's see what is the meaning of this. Suppose we have a reaction H2 plus Cl2 gives us 2HCl. Now, H2 is a gas, Cl2 is a gas, and HCl is also a gas. So, here it is not necessary, okay, these should be the gas. This could be anyone. I don't care about these. But here, reactant should be gas. Okay, now see. They say 1 volume of H2 reacts with 1 volume of Cl2. From where I am getting this one? One is nothing but this is stoichiometric coefficient. From where I am getting this one? This is nothing but your stoichiometric coefficient. So 1 volume of H2 reacts with 1 volume of Cl2. And since product is also gas, so we get 2 volume of HCl. But not necessarily here we will get 2 volume. If suppose HCl was liquid, so we will not say we got 2 volume, because this law is completely valid for gases only. Now let's see. Here they are saying if 1 volume of N2 reacts with how many volume of H2? 3. From where this 3 is coming? This stoichiometric coefficient. And since NH3 is gas, so we are forming how much volume of NH3? 2 volume. Clear? Good. Now you can easily derive this relation. How? I have already told you that 1 mole of N2 is reacting with how many moles of H2? 3 moles. And how many moles of NH3 are being formed? 2 moles. Okay. Now, what is the volume of 1 mole of NH3? 1 mole of gas? 22.4 liter at STP. Okay. So let's write it 1 into 22.4. So what is the volume of H2 required? 3 into 22.4. And what is the volume of this form? 2 into 22.4 liter. Clear? Now I hope you can see if 22.4 reacts with 3 into 22.4 to give us 2 into 22.4 liter of NH3. So I think 22.4 can be cancelled out now. So 1 liter will react with 3 liter of H2 to give us 2 liter of NH3. Or let's say if we have 1 ml. So 1 ml will react with how many ml of H2? 1 ml of N2 will react with 3 ml of H2. And with how many ml of NH3 will be formed? 2 ml. You're getting this thing. So this is your Gaseous law of combining volume. Gases always combine in simple volume ratio. See, it is not like if 1 ml is combining with root 3. Okay, simple ratio, are you getting the meaning? If 1 ml is not combining with root 3, means this is rational number, pure rational, it's not irrational. So 1 is combining with 3. So maybe if I have 2 ml, so 2 will combine with 6. If I have 3 ml of N2, so 3 ml of N2 will combine with 9 ml of H2. Like that. Is this clear? Let's move forward. Now let's see one problem. They are saying in a vessel, 2 liter of C2H6 and 9 liter of O2 was taken. Okay. They are saying that combustion reaction was carried out. We perform the combustion. Now combustion, what happens? It is nothing but reaction with O2. Now they are saying that after the reaction, gases were cooled to the current temperature. What is current temperature? Current temperature means whatever the temperature of the room. So they brought up after combustion, what will happen? Temperature will rise. Energy is released in combustion. So after some time, when combustion reaction was carried out, so product was cooled till what temperature? Room temperature. And they are asking to find volume of mixture present in vessel. Okay, now let's see. So what will be our reaction? Our reaction will be C2H6 will be combining with O2 to give us what? Combustion reaction. Balance it on your own. So it will be 2CO2 plus 3H2O. and here I will write 7 by 2H2O2. Okay, this is the combustion reaction of C2H6. C2H6, 2CO2 and 6H2O. 6H2 means 3H2. Now, very good. Now, they are saying if we have 2 liter of C2H6 here, and how many liters of N2O2? We have 9 liter of O2. So we have to find the volume of gaseous mixture. Now tell me one thing. If in the reaction, what will happen? What is C2H6? C2H6 is a gas. It is ethane. What is O2? O2 is also a gas. Now what is CO2? CO2 is also a gas, isn't it? Now what will be water at room temperature? Water will be at 25 degrees Celsius. That means it will be liquid. Now you just tell me one thing. If you know who has more volume, liquid or gas? So gas has immense volume as compared to liquid. So whenever we will have liquid as well as gas simultaneously, so with respect to liquid, with respect to gas, we will neglect the volume of liquid. Are you getting this thing? See, 1 mole of gas has how much volume? 22.4 liter at STP. 1 mole of N2 means how much weight? 1 liter of N2 means 28 gram. It has 22.4 liter at STP volume. Now what if I take 1 mole of H2O? 1 mole of H2O means 18 gram H2O. 18 gram H2O has just 18 ml volume. So can you see the gap? So remember this thing. If you have liquid, if you have gas together, so neglect the volume of liquid as compared to gas. So if we will be calculating the volume of final mixture, so we will not consider the volume of H2O. No need to consider. Okay. Now let's solve this question. Now we have 2 liter this and 9 liter this. Our first step will be, we must find limiting reagent. Without finding limiting reagent, you should not proceed the question. How will we find limiting reagent? Let's see. Now here in the rough, I will divide, let's see, I will divide this 2 by 1, stoichiometric coefficient. Now this 9, I will divide by 7 by 2. Okay, what I am getting, let me see. So I am getting 18 upon 7 here, 2 here. Who is smaller? This is smaller. Okay, if this is smaller, that means this belongs to what? C2H6. So now who will become my limiting reagent? C2H6. This is your limiting reagent. Just like we used to do calculation in moles, here we are doing calculation in terms of volume. Okay, so during the reaction, who will get consumed? C2H6. Now how much volume we have here? 2 liter. How much volume of O2 we have here? 9 liter. Now tell me, product amount will be decided by what? Will be decided by O2 or will be decided by C2H6? It will be decided by C2H6. So look at this relation. If 1 C2H2 forms how many CO2? 2. 1 C2H6 forms 2 CO2. So 2 liter of C2H6 will form how many liter of CO2? It will form 4 liter of CO2. Are you getting this thing? Here in this arrow, what is written? It is written forms. If 1 C2H6 gives us 2 CO2, so 2 liter of C2H6 will give us 4 liter, just double. Clear? Good. Now, can you tell me, 1 C2H6 reacts with how many O2? 1 C2H6 reacts with 7 by 2 O2. Let me write this. 1 C2H6 reacts with 7 by 2 O2. Can you see this thing? It is written in this relation. If we will have 1 C2H6, it will react with 7 by 2 O2. Now, but I have how much amount of C2H6? I have 2 C2H6, yani 2 liter of C2H6. So it will react with, can you tell me how many liter of O2? It will react with 7 by 2 into 2, that is 7 liter of O2. Means how much volume of O2 has reacted? 7 liters. Okay. Now why I am finding volume of O2? Why is the requirement of finding the volume of O2? Because they are asking find final volume of mixture present in vessel. In final mixture, what I will have? I will have product. Okay, I will have product as well as left reactant, isn't it? In final product, what I will have? I will have product as well as reactant which is left. That means excess reagent. So finally, we will have CO2 as a gas and O2 which is what? Left. Okay. Now how much volume of CO2 we have formed? 4 liter plus How much volume of O2 is left? See, we took how much volume? 9 liter. How much reacted? 7 liter. So how much left? 9 liter minus 7 liter. That means 4 liter plus 2 liter, that is 6 liter will be the final volume of our mixture. It will include CO2 as well as left O2. Is this thing clear to us? Good. Now let's move to a very important concept of this chapter called mixture analysis. I hope you are getting by the title only. Mixture analysis, we have to analyze a mixture. What will happen? They will give us a mixture of reactant. They will give us some reactions. One or maybe more than one reactant will be reacting there. So based upon the quantity of reactant consumed or quantity of product formed, we will have to form relations, means equations. And by solving those equations, we can analyze our mixture. Okay, let's take a very simple example. Now, example is a 6 liter mixture of methane and ethane. It requires 15 liter of O2 for complete combustion. Find the composition of mixture. Question is clear? Good. Now, we are having 6 liter mixture of CH4 and C2H6. So, what should be our approach to such question? We assume some amount of reactant X and the other reactant will be total minus X. Okay. For example, I am going to assume here is CH4 is, let's say, X liter. So what will be the amount of C2H6 here? C2H6 amount will be 6 minus X liter. Okay. Now tell me, who will react with O2? Only CH4 or C2H6 or both? Of course both, because both can show combustion reaction. So I am writing here is CH4 plus, this is nothing but combustion equation of CH4. So what I will get? I will get CO2 plus 2H2. Okay. Now what about balance? What about this C2H6? So C2H6 plus 7 by 2 O2 will give us what? 2CO2 plus 3H2. Okay, we have made the reaction and now I can see that both the reactants are reacting with O2. Now what volume of CH4 I have? X. What volume of C2H6 I have? 6 minus X. Now I hope by looking at this reaction you can tell me if one volume of CH4 reacts with how much volume of O2? 2 volume of O2. So X volume of CH4 will react with how much volume of O2? It will react with 2X volume of O2. Are you getting this thing? So 1 react with 2. So X will react with 2X. Let me write liter as well. Now, similarly, here what is written? Here it is written if 1 C2H6 react with 7 by 2 O2. 1 C2H6 react with 7 by 2 O2. So 6 minus X will react with how much O2? It will react with, see, 6 minus X into 7 by 2. Unitary method. If 1 react with 7 by 2, so 6 minus X will react with 6 minus X multiplied by 7 by 2. So here in this arrow what is written? Reacts. Here in this arrow what is written? Reacts. Now, can you tell me how much volume of CO2 will be formed in first reaction? In first reaction, volume of CO2 will be formed X liter. Why? Because 1 CH4 forms 1 CO2. So X liter of CH4 will form X liter of CO2. But can you see any relation of CO2 here? Can you see any CO2 written over here? No. Means they don't want the relation of CO2 here. They want relation of what? O2. They have given you the amount of CO2 consumed. Can you see this thing? Now, by looking at this reaction, can you tell me volume of CO2 consumed in terms of X? How will I write? Volume of O2 consumed in terms of X. Can you tell me? See, in first reaction, how much volume is consumed? 2X. In second reaction, how much volume is consumed? 6 minus X multiplied by 7 by 2. Means like that. 7, 6 minus X by 2. Okay. And how much total volume is actually consumed? 15 liter. So, I'm writing here 15 is equals to 2X plus, if you solve this, you will get 42 by 2 minus 7X by 2. Okay. Now, let's solve this. So, 15 equals to 2X plus 21 minus 7X by 2. Now, 21, I am taking 15 there, 20 here. Okay, fine. So, it will be 15 equals to minus 3x by 2. 7x by 2 minus 2x will be minus 3x by 2 plus 21. So 3x by 2 will be equal to 6. So see, 3 is 2. So x is coming how much? Oh my god. X is coming as 4 liter. Now what is this x? X is nothing but volume of. It is nothing but volume of CH4. Now what is the volume of C2H6? 6 minus x. 6 minus x. So 6 minus x will be equal to how much? 2 liter. This is nothing but volume of C2H6. Are you getting this thing? So what we have to do again? Assume any amount from your own side. Again express the other reactant in the terms of x. Are you getting this thing? Let's move forward. Now let's see another problem. They are saying we are having a 1.84 gram of mixture of CaCO3 and MgCO3. Okay. Now upon heating, it was observed that mixture left a residue of 0.96 gram. Okay. Residue means whatever is left. Find percentage of CaCO3 in the mixture. Question is clear? Now let's see what is happening. They are saying we have a mixture of CaCO3 and MgCO3 and we are heating them. Now tell me, what will happen if I heat CaCO3? I told you some important reaction in the very beginning. So CaCO3 will convert into CaO plus CO2 and similarly MgCO3 will give you MgO plus CO2. See, CO2 is a gas, so it will simply leave. Okay, and CO is a solid, so it will be deposited in the bottom. Okay, now this is your residue. Okay, now when you have two reactant like this, so you have two options of solving this question. This question you can solve exactly by the same method as we did in the previous question. But here we don't have liquid here, we don't have gas here. They both are solid. So there are two methods. Either you assume weight of CaCO3 on your own, or you assume some moles of CaCO3 on your own. So if you want to assume weight, then 2 it is good. If you want to assume moles of CaCO3, that is also correct. Okay, so I will be assuming moles here. So let's assume the moles of CaCO3 are X and moles of MgCO3 are Y. If I had assumed weight, so I would assume CaCO3 weight X. Then MgCO3 weight will be how much? It will be 1.84 minus X. Are you getting this thing? This is how I can approach, either by this or by this. Now why am I assuming moles here directly? Because I need to make calculation in moles. I always can make calculation in terms of moles. I never go for weight because weight relation comes a little bit lengthy and it is difficult also. So I will not assume this. I will not suggest you to go by assuming this weight. But if you solve by assuming X gram of CaCO3, it will give you the correct answer. If you wish, or I will suggest you try this method, you try this weight method on your own and write in the comment section whether you succeeded or not. Okay, now let's see. So I have assumed X moles here, Y moles here. Okay, now 1 mole of CaCO3 gives how much moles of CaO? It gives us X moles of CaO. So sorry, 1 mole gives us how many moles of CaO? 1 mole. So X mole will give us X mole of CaO. Okay, and similarly, how many moles of CO2 will be formed? 1 CaCO3 forms 1 CO2. So X moles will form X moles CO2. Okay, now let's see here. 1 MgCO3 produce how much MgO? 1 mole. So X mole, Y mole will produce Y moles. Are you getting this thing? Now we are not writing that much. We are directly writing in the arrows. What is written in this arrow? Gives. After some time I will stop writing this gives also. Now let's see. So Y moles here will form how much of volume weight of how many moles of CO2? It will form Y moles of CO2. Clear? I hope no problem should be here. Good. Now, if I ask you what is the what is the weight of CaCO3 present in the mixture? What will you say? Let me show you. Weight of CaCO3. It will come how much? It will come as moles multiplied by molecular mass. Okay, do you remember this relation? Moles equals to weight upon molecular mass. So weight equals to how much? N into M. Okay, like that I wrote this. So here it will be 100x. And what will be the weight of MgCO3? Weight of MgCO3 will be how much? It will be Y into 84. What is 84? 84 is the molecular mass of MgCO3. How much you will get? You will get 84x. Okay. Now, from here, I can directly produce one relation. I can directly produce one relation. And what is that? I can produce, can you tell me what is the total mass of mixture? 1.84 gram. So I can directly write 100x plus 84y is equals to 1.84. Clear? Weight of CaCO3 plus weight of MgCO3 equals to 1.84. Okay. Now, do you know what is the molecular mass of CaO? CaO has molecular mass 56. And what is molecular mass of MgO? MgO has molecular mass 40. Okay. Now, what if I tell me what I have written here. See, 56x. 56x. What is 56x? 56x nothing but the weight of CaO present. This is residue I am talking about. Plus, what is, tell me this, what is 40y? What is 40y? 40y is nothing but it is weight of MgO present. Equals to how much? This is nothing but your residue. So can you tell me what is the residue weight left? Residue has weight 0.96. So it will be equal to 0.96 gram. Are you getting this thing? Okay. Now, can you tell me what I have written here? Just tell me what I am writing here. 44x plus 44y. What is 44x? 44 is the molar mass of CO2. 44 is the molar mass of CO2. So 44x is what? Weight of CO2 produced by CaCO3. Weight of CO2 produced by CaCO3. How many moles of CO2 was produced? X moles. What will be the weight of X mole? 44 into X. Okay. Now, how many moles of CO2 was produced by MgCO3? Y mole. So what will be the weight of MgCO3? So what will be the weight of CO2 produced by MgCO3? 44y. Now can you tell me this value? How much it will be? See, this is your total weight in the beginning. This is the weight left. And what will be this? This will be called your weight loss. This will be called weight loss because CO2 is leaving your system, isn't it? Now, how much it will be? It will be 1.84 minus 0.96. How much it will come? 0.88. Is this thing clear to us? Now, I have two unknown, x and y. And I have got how many equations? 1, 2, even 3 equations. So, by using these 3 equations, you can easily find the value of x and y. Okay. Now, let's try to find that. So, I will take the help of this first and third. Why third? Because I can see here same coefficient of x and y. 44 here, 44 here. So, it will be easier for me to solve by this third equation. If you wish, you can solve by this also, second also. Okay. Now, let's see. I hope you can see here 44x plus 44y is equals to 0.88, which means x plus y will be equals to 0.88 divided by 44. Okay. Now, let's multiply this equation by, let's say 100. Okay. Let's multiply this equation by 100. So what we will get? 100x plus 100y equals to 88 by 44. 0.88 will become 88 once you multiply by 100. Now let's see. One more thing is coming. One more relation is there. 100x plus 84y is equals to 1.84. Can you see? 100x plus 84y. Now, subtracting these two, what I'll get, let's see. So if I cancel out, so see, minus, 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 so 100x will be cancelled out. 100 minus 84y will be how much? 16y. It will be equal to how much? See, 88 by 44, it is coming as 2. So 2 minus 1.84 means 0.16. 0.16. So y will be coming equal to how much? 0.01. You're getting this thing. So how many moles of MgCO3 I have? 0.01. Now let's find the value of y as well. See, I have already calculated here x plus y is equal to how much? 0.02. X plus y equals to 0.02. Y is 0.01. So x will also come as 0.01 mole. Is this clear? What is x? X is moles of CaCO3. What is y? Y is moles of MgCO3. Okay. Now let's find the weight of CaCO3. Weight of CaCO3 equals to how much? See, 100x. 100x means 100 into 0.01 means I'm getting as 1 gram. I'm getting as 1 gram. Now, percentage of CaCO3. How will I find the percentage of CaCO3? Percentage formula for CaCO3 will be how much? It will be weight of CaCO3 upon total weight of mixture multiplied by 100. Do you know this much? Percentage finding? Good. Now, 1 upon 1.84 multiplied by 100. Okay. You just have to calculate this and tell me how much it is coming. So it will come as 54.3%. Okay. Good. Now, next question is, if we have 12 gram of carbon and 20 gram of O2, we took them in a vessel and we performed a reaction. They are reacting completely and they are forming CO and CO2. You just have to find the moles of CO and CO2 formed. Okay. Question is clear? Should I repeat? We have carbon, oxygen, they are reacting and they are forming not just one but two compounds. One is CO and one is CO2. You just have to tell me what is the moles of CO and CO2 formed. Okay, please pardon the background noise. Now, so for such question again, I am having two reactions. C plus O2 gives CO2. Okay, one reaction is this. Let me write it like this. C plus O2 gives CO2. One reaction is this. And one reaction is this. C plus half O2 gives us CO. So carbon and oxygen are reacting in two manners. They are reacting in two manners. Let's see one more time. So some amount of carbon will be consumed here and some amount of carbon will be consumed here. I hope you are getting this. Some amount of carbon will be consumed here, some amount of carbon will be consumed here. But amount consumed here plus amount consumed here will be how much? It will be 12 gram. Okay. Now same amount of O2 will consume here and some amount of O2 will be consumed here. But total amount will be how much? 20 gram. Okay. So let's do one thing. Let's assume some moles of carbon reacting here and some moles of carbon reacting here. So first of all, let's find the total moles of carbon. The total moles of carbon. How much total moles of carbon we have? We have 12 upon 12, that is 1 mole. We have taken 12 gram of carbon. Now, how much moles of O2 we have? Moles of O2 is equal to how much? It is 20 divided by 32. Means 5 by 8 moles. Oh my god. You can see this thing. 20 by 32 means 5 by 8 moles. Okay. Now let's see. So let's assume the X moles are reacting in this reaction. X moles of carbon are reacting in this reaction. So how many moles of carbon will be reacting here? 1 minus X moles. Now pause the screen and try this question on your own. Okay. Now, since X moles of carbon are reacting here and I can see if 1 mole of carbon react with 1 mole of O2. So X mole will react with how many moles of O2? X moles. Okay. Let's see here. X mole, 1 mole of carbon react with half mole of O2. So 1 minus X will react with half into 1 minus X mole of O2. Okay. Now, moles of O2 reacted. Moles of O2 reacted in terms of X. How much? X plus 1 minus X by 2. isn't it? How much it will be? 2x plus 1 minus x by 2. I took the LCM. How much? X plus 1 by 2. Now they are saying x plus 1 by 2 is equal to how much? 5 by 8. From where it is coming? This is what is x plus 1 by 2. X plus 1 by 2 is the moles of O2 reacted. And how many moles of O2 I took? 5 by 8. So from here, I hope you can see it is cancelled out by 5 by 4. So x is coming as 5 by 4 minus 1 is 1 by 4. Means moles of carbon reacted here will be how much? X. Now x moles of carbon will form how many moles of CO2? X moles of CO2. And see here, 1 minus x moles of carbon will form how many moles of CO? 1 minus x. How? 1 mole forms 1 mole of CO. 1 mole forms 1 mole of CO2. So x moles will form x mole of CO2 and 1 minus x mole will form 1 minus x mole of CO. So this is your what? Moles of CO2. Now moles of CO will be how much? Moles of CO will be how much? 1 minus x means 1 minus 1 by 4, that is 3 by 4. I hope this question is clear to us. Good. Now, in this video, let's leave up to here only. Please find the DPP. Link is given in the comment section and in description. Solve that. Whatever doubt arises, ask me in the comment section. Okay. Have a good day. Bye.